All right. Good morning and happy Wednesday, I guess. So today I wanted to walk us through Git. Also walk you through getting your environment and stuff configured. So so anyway, this is my GitHub repository. It's linked in the syllabus, but you should be able to also just find it if you type in github.com/smileschen. So my name with an S in front of it. And then I think there should be a starred repository for 26 Spring Stats 21, and that's the repository for this class. Okay. And then I have this PDF that talks about getting set up and whatnot. So we can take a look at that. And then to kind of simulate the idea of setting up and walking us through this, what I'm going to do is I have this. How do I have virtual desktops? So I'm going to switch over to my other desktop over here, and this is to represent like your computer, okay? And what you would need to do for that. So actually, I guess over here, maybe I'll pretend to um, open up like a new window or something. So this, this will be a different account, and so I'll go to GitHub, Smiles Chen, and then so this is what it'll look like when you're not me, and this will be the repository, and you should still be able to see all the stuff, okay? And what we want to do is we want to get everything running. So this is a Linux virtual machine on my computer, and this again is supposed to simulate what your thing is like. And so you should, I imagine, if you're on a Mac, you already have Git installed. You can just type in Git dash dash version, and if you get something back like this, it means you have Git installed. If you don't, you'll have to go to Git SCM, and then you'll want to install it. And so you can look there. You have install for Windows, but then there will be other instructions for how to get it installed on, say, Mac. There's going to be commands that you can use and things like that. Okay. What you will need to do is you will need to configure. If this is the first time you've ever used Git, okay, you're going to need to configure it so it has your username and email address. Okay, so on when I pretend to be a student, I have a account that I can use, mileschen@ucla.edu. I forgot my password, so give me a second here. Okay, my password is do 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 do. Oh gosh, I need a two-step verification. 1 second. Okay. All right, so this is me pretending to be a student, okay? This is Miles Chen dash student, and so this is my repository. Okay. All right, so I don't have any repositories. This is me when I look like I'm 12, but I was like 20 years old in this picture. Right? Okay. And then so what I need to do here is I need to configure my GitHub account to I need to add an SSH key. Okay. I need to add an SSH key to my account. I need to configure an SSH key on my machine. And I also need to, well, first I need to configure Git, okay, on my machine. So I'm gonna have to do a git config, okay, and I'm gonna do -- global, and use the email address associated with your GitHub account. So if you haven't created a GitHub account, you need to create a GitHub account. So this is going to be mileschen@ucla.edu. You'll do whatever it is for yours, okay? Git config global user.name, and you'll type in your name, okay? And this is just so that every time you make a commit on Git, it will work, okay? You'll also need to install Visual Studio Code. I'm going to skip over that. You'll also need to install UV, okay? And this is our package manager. So full disclosure, there's lots of different package managers out there. There's pip, and there's Conda, there's Poetry. You can use all of these things to manage your packages, manage your virtual environments, all of these different things. And UV is the one I've chosen, and I've written instructions for that, okay? But you'll need to install UV, and so you can copy this command, curl-lssf, and type in the URL for that. Or if you're on Windows, you type in PowerShell. You'll have to bypass your execution policy because PowerShell's default settings is to prevent random scripts from running. And so you say, no, I'm okay with a script running here and things like that. Okay, but anyway, what we want to do now is we want to generate an SSH key, okay? And so actually, I have some lecture slides here as well, okay? Covering Git basics here. And the Git is a bunch of things. It's primarily a version control system. And you can think of this as like a time machine for your computer. So as you're working, you work on your file and you update it, and then later on you update some more, you write some more things, and with essays, it's generally you're moving forward and you're making progress. But as you're coding, sometimes you write things, you make features, and then those things like break things that you had earlier, okay? And then you might feel like, okay, I need to undo what I did. So you find yourself in a situation where you wish you could go back in time, right? I mean, sometimes that happens with an essay, but it's I would say it's less common in essays, more common in these programming coding situations where you write something, you change some of your code, it ends up breaking other stuff, and you say, okay, I need to go back in time, and you can only hit Control-Z so many times, or maybe you already saved it, and then so you feel. So anyway, what Git does is it acts as a time machine, and as you create these checkpoints in time. Okay, you create these snapshots, and they're kind of like if you play a video game, they're like save points. Okay, and so you can kind of load up an old save point, right? So I don't know, I play video games, and sometimes before you go into a boss battle or something, before you have to make a big decision, you create a save point, and then maybe you do the thing, and then you go, oh, that didn't work out, and then you can load up the old save point. And that's kind of like what Git is. Okay, you create these save points, we call them snapshots or hashes, and as you work, hopefully you're making progress and things get better, and you just kind of add these things. But sometimes things go wrong, and you feel like you need to go back in time, and Git allows you to do that. You can also, there's lots of things that Git can do. You can create like branching timelines where it's like, okay, what if I explored this other thing? You might want to develop some experimental features that you're not ready to put in the primary product and things like that. So you can create these branches where you can explore stuff, and then when it's working, then you merge it back in and stuff like that. Anyway, basically with Git, you create these snapshots, all of these changes are tracked, and you can always kind of revert back to an older version. Okay, and so anyway, with Git, these are the kind of the most basic commands. All right, and that is you add the changes that you want to commit, and then you commit those changes. Okay, so there's two stages here. Okay, and then git status kind of just lets you know what's going on in your repository. I recommend just typing git status every single time. Okay, every single time you do something, type git status afterwards. Okay, until you start getting really comfortable with using Git. But in the beginning, it's always good to just like git status will never break anything. There's nothing ever goes wrong if you type in git status. It's just like, hey, what do things look like? And if you type in git status a whole lot, then you start to understand. I think, all right, it was very helpful for me in understanding what Git is doing, what exactly each command is doing. So every time I type in a command, I type in git status afterwards. I think it's a good habit. Okay. You create your snapshots using commits, git commit. Okay, and there are two parts to creating a snapshot. You stage your changes, okay, but with using git add, and then you commit your changes into basically you create your snapshot in the timeline using git commit. Okay, so it's almost like three things in that, like, you're working on your computer and you just hit Control S to save the file. Okay, that just changes stuff in your working directory. Git will notice that and it'll say, I've got some untracked changes. Okay, if you want to start tracking those changes, you add them. Okay, you do git add and you say git add this file, and it says, okay, now I'm tracking these changes. And then to commit them, you type in git commit, and you're like, why do this sounds really complicated? I used to just hit Control S or Command S, and that would save it. Okay, and this is basically we are adding a little bit of kind of explicit steps into the save process, because once you write to the timeline, it's like permanently in history. Okay, you cannot. Well, I shouldn't say you can't, but you don't want to. You don't want to. Once you lock in a snapshot in the timeline, you don't want to erase that. Okay, that snapshot should stay permanent. Okay, and if you want to undo it, you can do that. Okay, but what that looks like is basically you've created this moment in time. All right, you create another moment in time, another snapshot in time, and you say, I don't like this. Okay, so what you do is you create another snapshot that reverts it, and it leaves this moment in time, and it leaves this moment in time, but it basically brings this moment in time back forward. Okay, it like undoes the changes. Okay, so the moment in time that you don't like still is there. Okay, rather than deleting it from history, it's like you have this moment in time, the moment in time that you don't like, and you revert back to the other moment. So it's still part of the history. It's still part of that timeline. But you know, that's how it goes. And you want to kind of explicitly make these changes. And so I wrote, why do we have git add and git commit? Okay, so every time you put a snapshot in your timeline, okay, the commits to your repository, we want them to be these logical incremental changes. Okay, and you can say, all right, at this commit makes this change, this commit makes this change, and this commit makes this change. You don't want to just change like 50 files all at once. Okay, but when we're working on the computer, we often have like 10 tabs open. We often have 10 different files open, and we're making little changes here, little changes over there, little changes, things like that. And so rather, like if you say create a snapshot, it's going to be like, okay, 10 files were all updated. Okay, and then you create another snapshot. All 10 of these files were all updated. Okay, and so that's not going to be the ideal way to do your commits, because as you're searching your history, you're like, okay, wait, 10 files are changed here, and then also 10 files are changed here. And like, I like these change and that change. It's too messy. So you might be working on 10 files at once, but then you say, when you create a commit, you say, just add file A and commit that change. Then you create a separate commit, file B, commit that change. File C, we made changes, commit that, all right? And then you can look in your timeline and you say, oh, you know what? I want to go back in time and I just want to go back to the older version of file B, okay? And then you can find the commit that corresponds exactly to when file B changed. So it separates, basically, instead of, you can say like, add all 10 files all at once and make a commit here, okay? But if you want to kind of untangle your changes and things like that, it's good to have separate explicit changes. And you say, this is the commit where I changed file A. This is the commit where I changed file B. And this is the commit where I changed file C. And then, okay, I don't like how file C changed, so I want to undo that one. I can basically revert the changes, basically kind of undo the things in file C and stuff like that. So that's going to be, that's why we have a separate thing where you say, these are the files I want added to this commit. And these are the files I want added to this commit, okay? All right, and so yeah, if you want to look at a previous version of a file, you can check out. You can go back, you have a log that says like, okay, these are all of the commits. This is the file, this is what file C looked like. This is what file B looked like at this time, and things like that. You can check out the older version, okay? You'll have a log that says these are all of the changes. You can check out the older version of that file. And then once you like that, you can make those changes. You can commit them and things like that. Your homework right now, so I think right now you have DataCamp homework, shell, which is like changing directories, listing off the contents of your directory just so you get used to working from the terminal. And then you have another assignment on DataCamp that involves Git. And so hopefully some of these things, like maybe I don't know if you haven't started your DataCamp homework for Git, that's fine. But you will see these commands again, okay? Or maybe you've already seen them, but anyway, it's good to have multiple exposure just because it takes a while to get used to it, okay? So anyway, that's Git. That happens on the local machine, okay? And then there is a service and a website company, I don't know, called GitHub, right? And GitHub is not the same thing as Git, okay? It is a company now owned by Microsoft, but that uses Git and is a place that hosts remote repositories, okay? So your repository when you're using Git exists on your local computer, okay? But sometimes you want to collaborate with someone else, okay? And so you don't have to use GitHub, but you can create a server and you can create a Git server and you create a remote repository, and basically your local repository talks to the remote repository, your collaborator talks to that remote repository and things like that. And GitHub is it's probably the most popular service as far as hosting Git remote repositories. There are other companies. What do I have? GitLab, Bitbucket. I don't know. There's a bunch of companies that exist out there that host remote repositories, and they have different, they will say like, we don't, like when you go to GitHub, they'll say like, and when you accept the terms and conditions, they'll say like, hey, we use AI and we use your repositories to train our AI and stuff, and you can opt out. And these other companies will say like, okay, we don't do that. All right, that's why you should use our service. Maybe we charge you for this, but we, give you privacy, So there's a bunch of companies that do this. GitHub, it's very popular. It's free. Yes, they use AI to train on your repository. So if you have like secret codes and stuff you don't want the AI to learn, that's fine. Okay, you don't have to use it. Well, for this class, I'm forcing you guys to use GitHub. Okay, but anyway, GitHub is a service that hosts remote repositories. And in order to use GitHub, you have to tell GitHub, this computer belongs to me, and this computer is allowed to make changes to my repositories. Okay, so you can create an account on GitHub, and you can log in. Okay. And then, but then you have to say, all right, this computer is allowed to make changes to my GitHub account. Okay. Allowed. And so we do that with an SSH key. So I'm going to walk us through creating an SSH key. All right. And so the command we're going to use is SSH keygen -t. This is what we're going to do. We're going to type in SSH -keygen. So this is on your computer. If you haven't done this already, maybe you've already done it and you followed all the instructions. Great. But I'm going to just show you what it looks like. And you only have to do this one time. Okay. So you create your key, SSH key. And here you use the one that's associated to your GitHub account. Okay. Don't use, make sure you use the same email address for all of these things. Okay. And so anyway, this is the command I type: SSH keygen -t ed25519 -C. This is my email. All right. Enter the file in which to save the key. The default location is in your home directory. My home directory is home/miles. And then it creates a new subfolder called .ssh. And then it's going to store the key in a file called ID ed25519. That's fine. I'm going to just hit enter to use the default. Okay. Then it says enter a passphrase. Leave empty for no passphrase. Okay. I recommend leaving this empty. If you have your own computer, it's probably fine. Like if you're doing this on a public machine that's shared with other people, then yeah, enter a passphrase. But otherwise, if you enter a passphrase here, you have to type in your passphrase every single time you make a commit, and it's annoying. So if you're the only one using your machine, then just leave this blank, okay? And then it says your public key has been saved over here, and your fingerprint is this, and great, okay? And so now I'm in my home directory. Right now, my home directory is completely empty. If I type in ls, I've got nothing. To see my SSH folder, which starts off with a dot, I type in ls-a, and now I have a folder in here that says .ssh. Oh, that is really hard for you guys to see. But it's anyway, so I can type in cd space .ssh, and I can list off the things here. And I've got, this is the private key, and this is the public key, okay? So what I'm going to do is I'm going to copy the contents of the public key, okay? So for me, I'm going to type in cat, all of this. I think I have commands for it to copy to your clipboard. You can do pb copy less than this, or clip less than this. And so here, I'm going to do ed255.pub, okay? And this just shows what it looks like. It starts off with SSH this, and it ends with your email address. This is the public key, all right? I'm not too worried about you guys seeing my public key because you don't have the secret key over here. And what I do is I take that key, I copy it to my clipboard. If you do this, these commands will copy it to your clipboard. And then in your GitHub account, you go to new SSH key, you paste the public key, and then this one I'm going to call, give, like, what is the computer I'm using? This is my Lenovo laptop, and this is my Linux, okay? Linux VM. For you, it'll be, whatever you call your computer, all right? MacBook, okay? You might have multiple computers. You might have like your MacBook, and then you have a home desktop PC. You have your mom's computer that you sometimes use or something like that, okay? Just give it that name. We add the SSH key. All right, and then so now I have an SSH key in my account, okay? And then so now that should work. I'm going to go back to my home directory. CD tilde takes you back to your home directory here, and that's what we have. Okay, so that should add it. All right, so then what I'm going to do, just to demonstrate, I'm going to create just a repository that's like not useful for anything. Okay, we'll also clone the class repository, but for now, let me just create a new repository. And okay, so to do this, just under your repositories, you just click the new button. I'm going to call this class demo. Okay, all right, you don't have to do this. All right, and then this description. This is a demo repository. Okay, for the class. All right, and then I like to add a README file. Okay, and it says, hey, do you want to add all of this other stuff? I'm going to just say no for now. Okay, but I'm going to say add a README file. I'm going to go ahead and create the repository. I'm doing this on the GitHub website, and so this creates the class repository. This creates a new repository in my student account here. And then what I want to do is I want to clone this repository to my local computer. So the way I do this is under class demo, I click this button that says code, okay? And then you've got these different options. I'm going to click the one for SSH, okay? SSH, there it says git at github.com/my user or :my username, and this, I'm going to copy this URL, this git URL, okay? I'm going to copy that to my clipboard, and then I come back to my terminal, and I want to clone this thing. So I'm going to type in git clone, and then I paste that address, okay? Git at GitHub, :my username, Miles Chen student, class demo, all right? I'm doing this in my home directory. Wherever you do it, it's going to create a new folder there, okay? So you don't want to do it inside your .ssh folder. You don't want to do it, I don't know, in like your stats 102B folder or something like that, okay? This is going to create a new folder wherever it is. So home directory, documents somewhere, okay? Okay, and then hit enter. And it'll say cloning into this. Oh, okay, this is the first time my computer's talking to GitHub. So it says, are you sure you want to do this? It says this is the fingerprint. I'm assuming my network is safe and hasn't been hijacked or something, but if you're in like some high security setting, they might have some kind of fingerprint for their server that you want to double check. Okay, I'm going to just say yes, this is fine, and then it says permanently added GitHub to the list of known hosts, and then it says enumerating objects, remote, this and this. Okay, so now if I list off the contents of my home directory, now I have class_demo, and I could change into it. Okay, class_demo. This is now I'm inside my Git repository here, and then and I can list off the contents here. The contents here is readme.md. That's it. I can edit. All right, so I can do edit this. This is a demo repo for the class, and I'm going to say, hey, I want to add, hello, my name is Miles. I'm a quote-unquote student learning Git. Okay. All right. So I'm going to add that, and I'm going to save it. On Nano, it's Control-O for whatever reason. Okay, and then I'm going to exit, Control-X to exit. All right. With this being a repository, I can type in git status. Git status says, on branch main, your branch is up to date with origin main. And look, there's changes not staged for a commit. We've modified readme.md. So I'm going to say, all right, well, let's add those changes. So I'm going to say git add readme.md. Okay, I can check git status now. If I do git status, it says, hey, these are changes that are ready to be committed. And then, and if I want to commit them, I type in git commit -m. You have to put a little comment, and so the -m is the little message that you want that is associated. We're going to say, hey, added a line to readme.md. Okay, and then that's that. I can say git status, and git status says, okay, on branch main, nothing to commit, working tree clean, but now it says your branch is ahead of origin main. Okay, origin being the thing on the internet, okay, hub. So to push the changes, because I added that line about like, hi, I'm Miles. If I want to push that, I type in git push. Okay, git push takes the changes I made on my computer and it pushes them to GitHub. And so now if I go to GitHub and I refresh my page, it now has this new line here, okay? GitHub. Hello, my name is Miles and I'm a student learning Git. Okay. GitHub also has the the ability to modify stuff. Okay. So on here I can like make changes and make a commit then. All right. And then I'm gonna write now I'm making changes to my README file on GitHub.com's website directly. All right. And then so I'm going to do this. I'm going to go ahead here. You click commit changes and we'll say update readme.md. That's fine. Okay. So I've done that. So now this has been updated, my class demo. But if I check over here and I say, hey, let me see what's the contents. I type cat for readme.md. Okay. This is still the old version. It doesn't have this new line. So what I have to do here is I have to pull, right? So the remote repository has been updated. My local computer hasn't caught up. So in order to get my local computer to catch up, I say git pull, okay? I'm going to pull the changes from GitHub to this, and it says, oh, okay, what we're doing is we've updated readme.md, and so now I can see cat readme.md, what's the contents there, and so now we can see the changes that we made on GitHub directly is reflected down here. Okay. And so this is kind of the basic steps as far as how you're going to get your computer to do a repository. So I recommend you can create a repository on your computer first. Like when you go through the DataCamp homework, it'll talk about using git init initialize to create a new repository on your computer. And then you can push that to GitHub. Just for simplicity, I always recommend creating a new repository on GitHub, a new empty repository, especially if you're starting off with an empty one. Creating a new repository on GitHub and then cloning it from GitHub to your local machine. It's going to have everything configured already, okay? Yes, you can start on your local machine and then push it to GitHub, but then there's configuration, and it's easy to make a mistake that then becomes frustrating later. So I recommend starting on GitHub, cloning it to your local machine, okay? And so this is how it works. Normally, you work on your local thing, you add those changes, then you commit them, and then once you commit them, you push those commits to GitHub. Okay. If things on GitHub have changed, okay, origin main, you call git pull, and then it pulls those changes to your local repository. All right. So the way I'm going to, oh, you know what? Before I forget. Let me give you your first two view quiz answers. The first two answers for today are E and C. E as in elephant is your first answer. C as in cat is the second answer. Okay? E and C. E as in elephant, C as in cat. Okay, so the way I'm going to distribute all files, your homework, all lecture notes, I'm going to do it through Git. Okay, I'm going to do it through GitHub. All right, so I have a repository for this class, putting them on GitHub, and then you're going to fork my repository, and you will pull your changes that way. All right, and I think, and in the beginning it'll feel clunky, but I think in the long run you will agree that this is a much more efficient way to distribute files and content rather than clicking and downloading things individually from Canvas. Okay, that's probably how all of your other classes work. That's how all of my other classes work, where I post things on Canvas one file at a time, and you have to download them, and then your downloads folder gets all crazy and messy. But with this class, I can say you guys are going to learn Git, and then now I'm going to distribute files via Git, and then we will all say this is what's made way better. Okay, but yeah, there's a learning curve. So okay, so in order for this to work, so again, I'm pretending to be the student over here. You are going to the professor's website, okay, GitHub or professor's GitHub repo. So you're going to go to github.com/SmilesChen. This is the professor. You're going to click 26 Spring Stats 21. That's the pinned repository you have. And this is what we'll do. We are going to, you're going to click fork. Okay, you're going to fork this repository to your GitHub account. So I click fork here. It looks like 30 students. So now it's going to say create a new fork. It's going to say the owner. This will be your name. So Miles 10 student. The GitHub repo is 26 Spring Stats 21. I'm going to go ahead and create a fork here. And so now this is on my account. All right, the student account. Miles 10 student. This is this, so it'll be your username, 26 Spring Stats 21, okay? And then now, what we're going to do is we're going to clone this repository, okay? So you're going to click the button that says code, right? And again, make sure you select SSH, not HTTPS or GitHub CLI. I mean, yes, there are ways you can use those things, but the instructions I'm giving you are for SSH, okay? And we're going to copy this URL to here, okay? And we're going to clone it to our computer. All right, now this is important. Make sure where the location where you clone it is the location where you're going to do it. So if you created a demo repository, do not clone the Stats 21 repository as a subfolder of your class or your demo repository or something, okay? So here I'm going to change directory back to my home directory, cd tilde, all right? And that takes me back to my home directory. Maybe I want to go to like documents. Maybe I want to go to, maybe you have a place where you have all of your academic classwork. You navigate to that folder, okay? And then you're going to type in git clone. And then when you type in git clone and you paste this address, it's going to clone your forked repository into a subdirectory. It's going to create a new directory there. All right, so here I'm in my home directory. I'm going to create a new directory in my home directory that is my forked repository. Okay, so I do that, and then it will clone it. Okay, so this is my, so now I have a forked repository. So now if I list off the contents, now I have the class demo repository. I also have 26 Spring Stats 21. So I can change directory to 26 Spring Stats 21. I can see the contents there. I've got completed notes. I got homework. So I can go to the homework folder. Okay. And then we've got a folder for homework 1. Oops. And then we can open that up and things like that. Okay. You can go back to here. There's completed notes. There's all of these other things. Okay. So if you've cloned this, what you'll want to do is you'll want to set up. So if you haven't done this, what you're going to then want to do is you're going to want to use UV to install Python. Okay, you're going to set up a virtual environment. So if you follow these directions, you're going to do UV VN for virtual environment, and we're going to do one for Python, and we're going to use version 3.12. Okay, so the most current version of Python is 3.14, but some of the data science packages and stuff haven't yet been updated for 3.14. So 3.12 is very stable. Most of the stuff all works with 3.12, no problem. So we're going to use that. Okay. probably next quarter it'll move up to 313 and things like that. But anyway, remember, this is like you want to kind of create these technology time capsules because code keeps constantly getting updated and the new versions of the packages don't work with the old version and stuff. So we're going to create basically a technology time capsule using UV, VMD, and we're going to type in -- Python, and we're going to do 3.12, and it's created that. And then basically the listings of all of the stuff, we're going to do UV pip install, and then thank you, Colin, for noticing that there was when I first configured it, I did it on my Windows machine. I didn't think anything of it causing conflicts with the Mac machines, but basically I've got two requirements files now, okay? And so we're going to type in UV pip install, okay? And then you're going to type in -R, and then you're either going to type in requirements Windows or requirements Unix, okay? So here we're going to do -R requirements -Unix.txt, and then and it goes, okay? And this is fast, okay? UV is like I don't know. I'm grateful for UV, how quickly it does all of the installations, okay? The older versions, like, it would take longer, but now it works. Okay, so anyway, so now my stuff is set up, and then we can let's see. Well, how do I want to do this? Okay, because I don't have my I'm on my, this is my Linux virtual machine, so I can't launch VS Code right over. It gets a little messy. So anyway, from there you can open up your folder in VS Code, and so let me switch back to the professor's computer. So on the professor's computer, I can come over to VS Code, and then basically your VS Code will look I don't know, something like this. And under Explorer, you can open up your Spring Stats 21 folder, and then you can open up like the Jupyter Notebook and things like that, and then you'll have the kernel. It should detect the kernel. It should say this is the 26 Spring Stats 21 virtual environment, and the kernel is Python 3.12. Right, it should recognize that. If not, you can click, if this is something, says select a kernel, you click this, and it should list off your installations of Python here. Okay, if you have other versions of Python installed, it'll list them all off here. We just have, you're starting on a fairly clean install, you'll have UV. Okay. All right, and then in the future, what's going to happen is as the professor, update my repository, you're going to want to pull those changes. The way this is going to work, I'm going to switch over to the pretend student computer, okay? One thing you want to do is you need to configure the professor's repository as an upstream repository. So if I type in git remote -v, this will show you your remote configuration. Right now, my remote configuration just says, hey, there's a link between this repository on your computer to GitHub, and currently it's linked to your username. So right now it's Miles Chen Student. Yours will say your name, okay? It'll be origin and then your GitHub username. Well, what we want to do is we also want to create another link to the professor's repository. So back on GitHub, okay, your repository will say forked from Smiles Chen 26 Spring. So this is, everybody's going to have the same upstream repository, okay? So you're going to come here, make sure it says Smiles Chen. That's me, the professor. You're going to go to code. Under code, you're going to copy this thing here. Okay? Copy the URL for the professor's repository. Everyone should say Smiles Chen because that's the professor's repository. And what we're going to do is we're going to add the professor's repository as an upstream repository. Upstream, kind of like things flowing down the river, okay? And so things further upstream get passed down to you. So I'm going to, me, the professor, I'm going to make changes to my repository, and we want those changes to flow down to you. So to do this, we're going to type in git remote add upstream, okay? And then you Control V. Let me just double check and just in case I typed something in wrong. But yeah, we want, where is, yeah, git remote add upstream, okay? So you're going to do git remote add upstream, and then you paste it. Make sure it says Smiles Chen, not your username. Smiles Chen, okay? So we're going to do git remote add upstream, and then you hit enter. And now if you type in git remote -v, which shows your configuration, okay, now there should be 4 entries, okay? There should be origin with your username, and there should be upstream, and everybody's upstream should say Smiles Chen, okay? And then, so come Friday, I'll have more stuff posted to my repository, and what you're going to do is you're, to pull those changes, you're going to do git pull upstream main, okay? And this is going to say, hey, I want to pull any changes from the upstream repository main branch of the upstream repository. Okay, right now there's nothing to pull, so if I hit type that and I hit enter, it's going to say already up to date. Okay, but by Friday, I, the professor, will post stuff I'll put changes to my upstream repository. At the start of class, I'll walk everybody through it, but you're just going to navigate to your cloned forked repository, and you're going to do git pull upstream main. That's going to pull all of those changes, and all of the stuff will appear on your local machine. Okay, so that is that's just a very, very, very basic intro, and as far as instructions for configuring, getting your environment set up for this class and starting to use Git. And so we're going to start there. On Friday, we'll post an actual Jupyter notebook that you can open in VS Code, and you should be able to see all of that. Okay, let me go ahead and give you your last view quiz answer. Third view quiz answer today is the letter B. B as in bear. B. Okay. If you have trouble with getting any of your stuff configured, come by office hours. I'm happy to help out, happy to help solve problems with your installation and things like that. But hopefully things go well. Okay? All right. That's it for today. We'll see you guys on Friday.